In this demonstration, we are unveiling Forward Networks support for Amazon AWS public cloud networks within our network assurance and verification platform. Forward Networks has pioneered the ability to verify the end-to-end behavior of networks and comparing that behavior to defined intent and security policies. We shift the focus from individual box-by-box testing to analyzing paths through the network and verifying the policy behaviors they allow. Our key innovation is the ability to model very complex networks and software in order to analyze the behavior and policies from the network design. We don't monitor live traffic or look at network logs. We mathematically verify the potential behavior of the network for all possible traffic and scenarios. This revolutionary approach moves network troubleshooting from a reactive exercise to a proactive methodology of error isolation and removal before an incident occurs, with the ability to verify high-level security policies and network intent in real time. This proactive, path-oriented focus that Forward Networks provides is only natural to now extend to hybrid cloud environments. Having the same visibility and policy verification for the cloud component of your infrastructure will greatly accelerate adoption of hybrid and public cloud deployments and simplify cloud operations. We know that compliance concerns and security controls in public cloud platforms are a major concern, and Forward Networks can now address many of those with the same insights and verification we have enabled for on-prem networks. We are starting with AWS VPC support, which is now available in our latest Forward Enterprise release. Let's start by looking at our AWS Virtual Private Cloud setup in the AWS dashboard. If you aren't familiar with AWS VPC Networks, they have modular components that include subnets, routing tables, load balancers, and internet and VPN gateways. In our demo scenario, we have two VPCs, Cloud 1 and 2. Each with their own route tables and set of ACL rules. We can select one to get a more detailed description, but it's not particularly well documented without drilling down on some of these configuration details. To get an idea of what each of these VPCs is doing, let's look at the subnets that reside in each VPC. Okay, it looks like we have 5 subnets running different applications. 2 web application servers and a database server, which are assigned to one VPC, and a mail server and an SSH server in the other. But what can we learn about how these services and subnets are connected? The ACL rules for each service provide a lot of insight. If we drill down on the database service ACLs, we can see that inbound traffic is allowed only for SSH access and database access from our only 2 web application server subnets. If we look at the ACL rules for the mail server in the other VPC, we can see it's generally configured to allow SMTP access from any source and other limited management access. If we look at the route tables, we can see that there are 2 route tables, a public and a private route table for each VPC. We can drill down on one of these, the public route table for VPC 1. We can see the available route is primarily from and to the Internet Gateway, and it's only associated with one subnet, which we might know is the mail server subnet if we had some documentation handy or we were pretty experienced in dealing with this VPC design. If I check one of the other private route tables, I see the primary route available is a peering connection between the data centers, so we know that they are connected somehow. And I know that we have a load balancer in front of our 2 web application servers, but to see how it's configured, I have to leave this particular dashboard and check the services for our EC2 workloads. We can see some basic configuration details for the load balancer, such as which VPC it resides in, and I can check the port listeners to see that it's balancing traffic for HTTP and HTTPS. The main takeaway from this run-through of our AWS setup should be that this is a pretty simple VPC design with only a handful of services and routing and access rules. But it is really hard to visualize what the connectivity is between applications and VPCs, what policies are in place for each service, and what traffic paths are available and supported. If you are supporting dozens of VPCs with a large number of services, many of which need to access each other, while also ensuring isolation between other groups of applications, it's very challenging to manage that many details without a lot of tedious effort. If you are migrating a large data center to the public cloud, it's easy to see the lack of visibility and policy controls compared to your on-premises network. Now let's compare what we have just seen with Forward Enterprise. We have already collected a snapshot of our current AWS VPC design we just went through. Immediately, we have a topology diagram of our two VPCs and see the connections from the gateways to the routing tables, subnets, and load balancer. The green links are bidirectional links, and the yellow links are one-way links. We see 3 gateways at the bottom, one of which is our internal VPN gateway, and the 5 application subnets at the top of the diagram, with the route tables in the middle. We can see all the possible traffic flows and connectivity in one screen between all network components and can check configuration details for each of the virtual devices. For example, we can drill down on that public route table in VPC Cloud 1 and see the same route table and subnet association we saw within AWS. In this case, the association with the mail server subnet for allowed SMTP traffic. But Forward Enterprise can do much more than visualize the topology and the connections. Let's move over to the Policy Verify tab. We have predefined a number of policy checks here for our two VPCs. Every time we collect a snapshot of our network from AWS, we will verify that these requirements pass so that we can immediately see if there are any policy errors in the new configurations or if any access vulnerabilities were introduced. Just going down the list here, we are checking our VPC design to ensure traffic is allowed from the Internet Gateway to the public subnets and back. And if we aren't sure what the public subnets are, we can mouse over the alias for this device group and see that it refers to both the web application servers and the mail server. We also intend for traffic through the VPN gateway to access the SSH server and return. The SSH subnet needs to reach the private subnets, which are the database and NAT gateway subnets. And there are a few more similar verifications down the list. The last check, however, is what we call an isolation check, meaning we want to ensure that our VPC design does not allow this type of traffic, specifically traffic from any of the internet gateways to reach the private subnets, including our database server. Let's examine a couple of these verification checks on our diagram. We select the pass-fail link for the check, and we can see on the topology exactly how traffic would flow to achieve this policy. For example, the check that verifies access through the gateways to publicly accessible services is shown here. Each conforming path is listed below the topology diagram, and we can select any one of them to see the behavior of specific devices in the flow, as well as details about how they are configured. In the case of the isolation check, the diagram shows that there are no supported paths. Traffic would be dropped trying to reach the private subnets, which is what we required. But what about hybrid cloud? Can we really extend these policy verification capabilities across AWS from on-premises networks? Let's start a new search and zoom out to see our whole network. Our AWS workloads are above left, and the much larger network consists of 2 on-prem data centers connected by an MPLS backbone. This network connects to AWS through an internet gateway in the Atlanta data center, a Juniper VMX edge router. We can see all possible traffic from this device to see that it reaches only specific application servers in our on-prem data center, that no traffic can reach the remote data center from this internet gateway, and only 2 of the AWS services are reachable from our on-prem data center, the SSH server and the mail server. This is a very simple query for all types of traffic from this internet gateway. We can refine this query in a number of ways, such as looking specifically at HTTP traffic. Now we see traffic on port 80 can flow to AWS still, per our configurations, but not to the internal servers. It is all being dropped at the firewalls. If we change the query to HTTPS, we can see that valid paths to the destination servers are again available. We can go back to our Verify tab and re-examine one of the predefined checks related to our hybrid cloud. We want to verify that traffic can flow from one of our core routers in the San Jose data center to the SSH server in AWS. We can see that check passes, and we can show in the topology how it flows through the MPLS core to the Atlanta data center and through the Juniper gateway specifically to the SSH subnet. If we wanted to modify this query slightly to check on whether similar traffic can reach the AWS database server subnet, we can see quickly that indeed, as expected, this is not allowed. In fact, let's add this new check to our list of standard verifications as a new isolation check to make sure this traffic is not allowed in future snapshots and collections. This has been a very brief introduction to the power of Forward Enterprise applied to AWS and hybrid cloud networks. A key takeaway is that for much more extensive and sophisticated AWS deployments, management complexity and policy assurance can quickly be overwhelming. With Forward Enterprise, you have an immediate way of visualizing the connectivity and policy configurations within AWS and can apply the same controls and verify compliance as on-premises infrastructure. And extending the visualization and verification of network paths and policies from across the on-prem infrastructure all the way through AWS can accelerate cloud deployments and simplify hybrid cloud deployments with a dramatic reduction in potential errors. If you'd like to learn more, check out our website at forwardnetworks.com, follow us on Twitter, or watch our other product and use case videos on our YouTube channel.